This is section 4.2, part D, Inference for experiments. In an experiment, researchers usually hope to see a difference in the responses so large that it is unlikely to happen just because of chance variation. We can use the laws of probability, which describe chance behavior, to learn whether the treatment effects are larger than we would expect to see if only chance were operating. If they are, we call them statistically significant. An observed effect so large that it would rarely occur by chance is what we call statistically significant. If we observe statistically significant differences among the groups in a randomized comparative experiment, we have good evidence that the treatments actually cause these differences. You will often see the phrase statistically significant in published research reports in many fields. The great advantage of randomized comparative experiments is that they can produce data that give good evidence for a cause and effect relationship between the explanatory and response variables. We know that in general, a strong association does not imply causation. A statistically significant association in data from a well-designed experiment does imply causation. Suppose researchers want to test whether a new detergent for clothes that requires hand washing clean better in warm and cold water. They decide to perform an experiment using numerous pieces of dirty laundry as experimental units. The response variable in the cleanliness rating is a scale of 0, very dirty, to 10, very clean. How should researchers deal with the fact that lighter colored clothes tend to come cleaner in warm water? They could use a completely randomized design and hope that the random assignment distributes the light colored clothes about evenly between the cold and warm water treatment groups. Even so, there might be a lot of variability in the cleanliness rating in both groups due to the color of the clothing. This lurking variable might make it difficult to determine a difference in the effects of the treatment. What should the researchers do? Since the researchers know that color may affect the cleanliness in a systematic way, they could start by separating laundry into two piles, one for lighter colors and one for darker colors. Each of these piles are similar experimental units, is known as a block. So within each block, the researchers could then randomly assign about half of the pieces of laundry to hand washed in cold and the other half to hand washed in warm water. The same person should do all the washing as a form of control. This randomized block design reduces the effect of variation among the experimental units due to color on the response variable. So for this laundry blocking experiment, we have many pieces of dirty laundry. We're going to assign to blocks is not random. We're going to assign the blocks. One block will be light colored clothing, another block will be dark colored clothing. So when you're blocking, you want everyone in the same block to have similar characteristics. Within the light colored clothing, you are then randomly going to assign them to cold or warm water and then compare the cleanliness of just the light colored clothing. For the dark colored clothing, again, you will randomly assign them to cold and warm water, and then you will compare the cleanliness of just the dark colored clothing. So a block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response to the treatment. In a randomized block design, the random assignment of experimental units to treatment is carried out separately within each block. Blocks are another form of control. They control the effects of some outside variable by bringing those variables into the experiment to form the blocks. A randomized block design allows us to draw separate conclusions about each block. Blocking also allows more precise overall conclusions because the systematic differences between the variables can be removed. The moral of the story is control what you can, block on what you can't control, and randomize to create comparable groups. When you go to take your AP exam, don't mix the language of experiments and the language of sample surveys or other observational studies. You will lose credit for saying things like, use a randomized block design to select a sample for the survey. Or, if you say, this experiment suffers from non-response since some subjects dropped out during the study. Women and men respond differently to advertising. Researchers would like to design an experiment to compare the effectiveness of 3 advertisements for the same product. Explain why a randomized block design would be preferable to a completely randomized design in this experiment. A completely randomized design considers all subjects, both men and women, as a single pool. The random assignment would send subjects to 3 treatment groups without regard to their gender. This ignores the differences between men and women and how they react to advertisement, which would probably result in a greater deal of variability in the response to the advertising in all 3 groups. So, if we were to assign these, we would first block them, women in one block, men in the other, and then we would randomly assign those people in the block to the different treatments. And for the women, we would assign 40 to group 1, 40 to group 2, and 40 to group 3. Group 1 would watch ad 1, group 2 would watch ad 2, group 3 would watch ad 3, and then we would compare the reactions. We would follow the same pattern with the men, randomly assigning 60 men to each group, and then having each group watch the different ads. A randomized block design would consider women and men separately. In these cases, the random assignment would occur separately in each block. Blocking will control for the variability in responses to advertising due to gender. This will allow researchers to look separately at the reactions of men and women, as well as to more effectively assess the overall response to the ads. So still looking at that same problem, outline a randomized design for 300 volunteers. We kind of already did that on that last slide. So you would separate the women and the men into different blocks, then within the blocks randomly assign the individuals to the different treatments. A common type of randomized block design for comparing 2 treatments is a matched pairs design. The idea is to create blocks by matching pairs of similar experimental units. Then we can use chance to decide which member of a pair gets the first treatment. The other subject in the pair gets the other treatment. That is, the random assignment of subject to treatment is done within each matched pair. Just as within other forms of blocking, matching helps reduce the effect of variation among the experimental units. Sometimes each pair in a matched pair design consists of just one experimental unit or one person that gets both treatments, one after the other. In this case, which treatment they receive first is what is randomized.